Good afternoon, everyone. It's my noon time. I'm on the East Coast. It's a pleasure, as I mentioned, to be here today to participate in our webinar and to give a course on an introduction to statistics for non-statisticians. I've been doing this for quite some time now. I'd have to say at least a year, so that's over 4 courses that I've been giving this webinar, and then I've also been teaching statistics at Tufts University as well. So a little bit about me, about your trainer. At present, I'm an Associate Director of the Health Outcomes and Payer Policy Group based out of Foundation Medicine, which we are a molecular diagnostics company based out of Cambridge, Massachusetts. I'm also an adjunct instructor at the Tufts University School of Medicine, as I mentioned, where I've taught med students introductions to statistics and epidemiology as well. My degrees are from Brandeis as well as Tufts University, and I have over 10 years of experience in drug development as well as 4 years of experience in economic consulting, which is also very stats heavy and stats based. And just to share, the examples that I'm going to be giving you today and that we'll be walking through come from a variety of sources. I can't take credit for all of them, so I just wanted to give a call out to my previous professors, Dr. Michel Izao, Dr. Jerry Dalal, and Dr. Olaf Daman for giving me a lot of the examples that we'll be going through today, as well as Dr. Sashi Satnayarayana, who provided the main example that we'll be working through as a class for all of us. So then for today's agenda, what we're going to do, as you mentioned, everybody's interested in having a refresher in statistics, so that's what this will serve for. We'll go over first recognizing and interpreting descriptive statistics. We'll talk about how to summarize continuous data with appropriate descriptive statistics. We'll then also interpret confidence intervals and explain how they are calculated. So moving from descriptive statistics into what's called inferential statistics and why we calculate those and what we do with them. We'll also talk about how to interpret p-values and explain the concepts behind hypothesis testing. So using students' t-test as the example that we'll be providing today. But all the concepts that I'll be talking about, while the mathematics behind them might be different, the concepts themselves stay consistent regardless of what test you're running. We'll also employ statistical terms used in clinical research, and we'll scatter a few of those terms throughout today's session. And then lastly, we'll close with identifying approaches to be more comfortable in communicating with statisticians. So also, this is also where we'll open it up to you, and I want to hear more about what some of the concerns have been historically, or alternatively, what some of the fears are moving forward if this is something that's relatively new for you. So with that, I'll start with opening up with what statistics is. And what it is, the definition of it is the process of understanding how to accurately summarize data and minimize the occurrence of a chance finding. So put in other words, right, the idea is to summarize the data that's presented to you, whether it's through a clinical trial, whether it's through real-world evidence, but in a way that everyone can understand what the data are saying, and on top of that, make decisions based on what the data are saying. So put in other words, statistics describes what all of the data are telling you. So for example, did the new drug work, right? Did the new device work? That's essential to know. Are the two groups that we're testing the drug in, so if we have a placebo arm or a control arm and the drug arm, are those two groups that are being compared similar, or are they different in some way? And or alternatively, if you're in the diagnostic space, is the new diagnostic test more precise than the older test? Let's talk a little bit more about, the analytical validity, that kind of thing. And so that is typically what statistics is and what it's used for in our field anyway, in pharma. And so there are two types of statistics, right? So we have descriptive statistics, which are analyses that describe the data itself. So, for example, anything the Census Bureau collects and reports out on, when they start talking about demographics or economic information, this is just a snapshot of the United States at that point in time when all of that data are collected. The thing with descriptive statistics is that there are no hypotheses or conclusions made about them, right? It's just a lay of the land. It's what we're seeing. And how we talk about the lay of the land and what we're seeing typically involves central tendency, measures of central tendencies and how the spread around that central tendency, which we'll talk about in a few slides. So that's descriptive statistics. Again, it's just describing the lay of the land. It's probably what we're most familiar with, all of us. Anyone who watches sports, there's always statistics thrown out with respect to descriptives as well.